So to get started, welcome to the first 7 days of ACI, and I figured I'd start off by talking about why we're doing this session. So first of all, my name is Carlo, the guy at the bottom there, and I will be co-presenting this with my good friend Joey. We both worked in ACI escalation. He works for the business unit. I worked in TAC up until a couple weeks ago. Now I'm a solutions architect helping customers design data centers. So how did we come up with this session? Back in the day when ACI first came out, I guess it's 3 to 4 years ago at this point, Joey went over to the ACI TAC team to help start it, and he said, hey, Carlo, you should come join me. It's a lot of fun. At that point, I worked on the data center switching team, and I loved what I was doing. I was doing routing and switching. It's what I really enjoyed. And I said, no, thanks. I'll stay where I am. About a year later, Joey came back and said, hey, you should really come. You know, it's not all application-centric programmability. It's what you like to do. It's routing and switching. So I decided to make the jump, move over to ACI, figure out what it's all about. And at the end of the day, it's about routing and switching, right? It's a network for your data center. So when it came time to do a Cisco Live session, we sat down and we said, you know what we should really do? We should talk to customers that know what a Nexus 2K, 5K, and 7K is, maybe a customer that has a 6500, and talk to them about doing ACI. So this is an introduction session, so we will spend a few seconds to talk about why ACI, but then we're going to walk through it like you just received your shipment of the APICs and the switches. You rack them. What's the next thing you do? How do you move forward? What are your fabric policies? What are your tenant policies? We'll dive into a high-level network-centric migration. That's when Joey will take over. Talk about multi-location deployments. So what are your options, right? We're not going to do OTV anymore. There's a lot of other nice stuff that we can do with ACI. And then we'll go into troubleshooting tools, right? That is our bread and butter. That's what we've been doing for 8 years now, is troubleshooting networks. And then Joey will finish it off with some additional resources that are available to you. So throughout this session, WebEx Teams, I have my good friends Andy and Joe over here who will answer any questions that you might have. Depending on how we're doing on time, I will try to answer some questions up here as well. The other benefit, though, of joining the WebEx Team space is I think the PDF should be posted. Now I'm starting to second guess that because we didn't have our session on this computer this morning, but maybe Joey posted it. In that case, thank you. If you are following along, let's see if I have a laser pointer on here. There is this little reference slide icon, and those are basically slides that we wanted to put in there to give you additional information, but we only have 2 hours, so we can't talk about everything. So if you're following along on the PDF and you see that little icon, we will not be talking about it up here. Okay, so let's talk about why ACI. What are the challenges that ACI is trying to address, right? And it starts with management. So a big thing with ACI is let's change how we manage networks. And in the past, you'd have to SSH to each device. The configuration would be manual, and that takes time, right? So if I want to deploy a gateway, or if, say, I want to do something like make a QoS change, right? I don't do that on one access switch. If I want to have a successful QoS implementation, I need to do that in my entire network, right? So we're going to each box, and as our networks are getting bigger, that becomes much harder. We also have to coordinate with the server team. So when I started in IT, that was back in college. I worked for my school's IT department. That was really easy. It was like 5 of us sitting in a room together. But over my years in TAC, I've learned that coordinating with different teams outside of maybe networking or security or servers can get a little difficult, right? All of a sudden, the case goes from progressing to, hey, we have to wait for these people to join the call. Let's sync up again tomorrow. So when we're deploying, let's say, VMware, and we need to add a cluster of ESX servers, we need to talk to them. We need to understand what networks do they need. So that all can slow things down. From a functionality perspective, our configuration has to be static. So it needs to be in place, right? If a ESX cluster is connected to 15 different switches, well, all the VLANs need to exist on all those 15 switches in case the server team decides to do vMotion, right? That all needs to just work seamlessly for them. My favorite thing is spanning tree, right? So back on DC switch, it was almost like every day when we would have an outage because of spanning tree. And if you think about how the protocol works, right, is you have these BPDUs that almost act as a hello mechanism. And when we stop receiving them and the link stays up, we decide, hey, maybe we should just go forwarding on all these links, right? That's the best thing that we can do. It doesn't make a ton of sense, right? Your network will go down. So how do we get away from spanning tree? OK, so I forgot my clicker doesn't work. Moving into ACI. Let's take a step back and let's talk about what ACI is. So ACI, at the end of the day, is a network built on Nexus 9000 series switches. Typically, we have a spine layer that will be made up of a Nexus 9500. Those are our modular chassis. But for smaller deployments, we do have something that we call a baby spine. It's a Nexus 9300. But they always, we build them out in a spine leaf architecture. So that means we have a layer of leafs, and those connect to our spine switches. To manage this entire fabric, we have a cluster of APICs. So the APICs are the central point of management for this entire network. It doesn't matter how big this gets. It is the APIC that you're going to. So what is the advantage of this? It makes it much easier to manage our fabric, to discover our fabric. Sorry, here we go. The entire configuration is managed by our APIC. One cool thing that we do with ACI is that we expose everything via an API. So if you want to just automate some of these deployments, everything that we do in ACI you can do with an API. We do have a GUI, which I'll get into. All of that is built on the API. There is nothing secret that Cisco does in the GUI that we built that we don't expose to you through the API. Our switches join the fabric with a click of a button, right? So this is really cool. If you want to expand your ACI fabric, you make sure they're running ACI code. You connect them to your spines, and they're going to show up on your APIC. You're going to give them a node ID, and they're part of your fabric. From a functionality perspective, so we're no longer running spanning tree. These are all routed links inside our network. We are running ISIS as our routing protocol. And if something was to go wrong and we stop receiving ISIS PDUs, we don't go in an all forwarding state and take down your network, right? So it's much more resilient. We have all the advantages of layer 3 networks baked into this. Our configuration is dynamic. So what this basically means is that the configuration will only get pushed to the leaf switches when it's needed, right? So we don't need to take up all these VLANs or push all these resources if we don't have anything connected to the switches that utilizes that. And then last is it's a whitelist model. So in the past, right, networks were built so things can communicate. And in today's day and age, we want to build networks and limit things and don't allow everything to communicate because that would be a huge security risk. Now, we did feel that it was important to put this customizable thing in here because when you migrate to ACI, you don't have to go to this whitelist model, right? So we understand that it is quite complex to understand what your applications are doing, and we are not going to force you to understand how every single application works. There is some flexibility with this, but in general, when they built ACI, the idea was let's use it to limit servers to only be able to talk to devices that they should be talking to. OK, so high level, how does this work, right? I plug in my APIC. I connect it to my first Nexus 9300 leaf switch. And through LLDP, my APIC will discover this leaf. It will send it some basic configuration. So we push a VXLAN tunnel endpoint address. That is basically an IP address that this leaf switch will now own. And the APIC can use it then to communicate with this leaf switch. So once we do that through LLDP again, we can discover the spine switches that this leaf is connected to. So the same process will happen again, right? These spines show up in your APIC GUI. You give them a node ID. We push a VXLAN endpoint or a VXLAN tunnel address. And once we do that, we can discover the rest of our fabric, right? So we have now dynamically configured the entire fabric. The APIC has given each leaf switch or spine switch an IP address. And on top of this now, we build a overlay or underlay network. So basically, between the leaf switches and the spines, we are running ISIS. So that is that each leaf knows how to get to every other leaf in the fabric. But then we also run BGP on top of this. So BGP is used if you connect ACI to your campus network and we want to learn some routes from your core network. We'll use BGP to make sure that all other leafs know how to reach those networks. Our APICs will cluster. So our APICs need to be able to see each other through the fabric. They will be fully redundant, right? So you can lose APICs and everything will still work. You can actually lose all 3 APICs and the fabric will continue to forward traffic. The APICs are just used for configuration management, so you won't be able to make any changes if your APICs are down, but your servers will still have connectivity. Okay, so now we start connecting resources to our fabric, right? So we might have a ESX cluster or a hypervisor cluster, maybe OpenStack. For those VMs or servers, we need VLANs so that they can communicate with the leaf switches. We need gateway addresses so that they can get to the outside world. And as these resources are connecting to the fabric, the APIC makes sure that we're only pushing whatever is needed, right? So here we have a border leaf, and for that border leaf, we only need to push routes for those internal networks. So if I was to summarize sort of in a few sentences of what ACI is, I would say ACI is a layer 3 network running ISIS that is configured automatically by your APIC, right? So you as the user, you do not have to understand how ISIS works. That is what Cisco is doing for you. We're a networking company. We built this underlay for you. On top of this, we are running VXLAN. And again, VXLAN, you do not have to understand how VXLAN works. We take care of all of that for you. So for those that don't know what VXLAN is an encapsulation technology, and we use VNIDs, basically unique identifiers, to separate layer 2 switching and layer 3 routing within this overlay network. And again, the whole beauty here is that ISIS, VXLAN, all of this, you don't have to know how it works. It is built for you by the APIC. So what is this APIC? We spent a lot of time talking about it. And basically, the way you access the APIC is a GUI. It's a web browser or a website that you go to. And when you connect to your APIC for the first time, you log in, you will see this controller status here. So this is basically telling you, hey, are my APICs fully fit? This is what you want to see. If you ever see anything different, figure that out or give TAC a call, right? But your APICs need to be happy. They need to be able to see each other. So then the next new thing that we have in ACI is we have a concept called faults. Faults are interesting because they work a little differently compared to what we're used to, right? So if you imagine you console into a 6500 or you SSH and you turn on termmon and you start configuring something, and you put in a misconfiguration or you fat finger something, right? You're going to see on the console real quick, like, hey, this didn't work, but then you move on, right? So if you just copy and pasted the whole script, you might not catch that. Well, with faults, what we do is when something goes wrong, we raise a fault, and this will stay there until you correct it, right? So let's say you misconfigure where you have an overlapping subnet or something like that. You're going to see a fault, and until you resolve that, it will not go away. So it's a nice way for you to see what's wrong here. This isn't limited to just faults, though, right? Let's say your power supply in one of your leaf switches dies, and it's not working anymore. Well, at this point, you're going to see a fault saying, hey, the power supply is bad, and until you go in and you replace that power supply, you're going to be reminded that there is an issue that you need to take care of. The other cool thing that we can do with this is that we can have this little health score, because we can associate a score to each fault, and there is a formula that we use, right? So something small isn't really going to impact your fault or your health score, but if a spine goes offline, well, you'd see this, right? And this can be very helpful if your server team comes to you and they're like, hey, between 5 and 5:30 yesterday, we had some connectivity issues. Can you look at your ACI fabric and see what happened, right? And well, if you log in here and you see that you had a little dip, it's obvious that, yes, in the fabric, we did see something happen. So we can zoom in on that and figure out exactly what it was. Okay, so moving towards the Fabric tab. So before we were on that System tab, the Fabric tab is where all our switches are. The nice thing here is we're always going to see our topology, right? The downside here is that in ACI, our topologies are typically much simpler than what people could do in the past. It's a spine leaf architecture. But you can still click on a switch, right? And you can see exactly on which interface do other switches connect. It makes it much easier to figure out how everything is laid out. This is also where you can get information about your switches, right? If you want to see what hardware it is, what software they're running, and so on. OK, so that was our quick overview. So we understand why ACI exists, why we might want to do it. Now we've received our APICs, right? We've racked our APICs, we've racked our switches. What are we going to do? Well, let's start off by talking about what the APIC is. It's a C220 server. If you have one of the newer ones, the 3rd generation, it has 4 VIC ports. VIC is the Cisco adapter on these APICs, and this connects to the leaf switches. This is what, through LODP, we will use to discover the first leaf switch, or after we've discovered the fabric. Through these interfaces, we can manage the switches. And then on your APIC, you also have 2 copper ports, and those are supposed to go to your out-of-band network. The point of this is that after you configure your APIC for the first time, you need to be able to get to that website that it's hosting so you can configure the rest of the fabric. So that is why you need to have these 2 connections up. They are running in an active standby fashion, right? So we'll only use one of those at a time, but it's nice to have some redundancy. The last thing to talk about here that is really important is your SIMC port. So SIMC, it's our IP KVM built into these servers, right? It's running independent of the APIC OS. And the first time you boot up your APIC, you need to hit, I forgot what it is, F8 or F6 or something like that, to actually configure your SIMC. So this is a different address from the address that you will give the APIC. But this will allow you to manage the server as the physical hardware of the server. So the cool thing about doing this is, right, so you rack your APIC, use your crash card to configure the SIMC. You can get back up to your desk to then configure the APIC for the first time. So when you're setting up your fabric, there's this initial setup script that we need to go through that gives the fabric some basic configuration parameters that it needs to get up and running. A couple things that are important to talk about here. The first is our TEP pool, or our infra TEP pool. These are the addresses that the APIC will use to assign to leaf and spine switches, or sort of anything else that you might, I want to say connect to the fabric, but if you extend the fabric to, let's say, an OpenStack host or something like that, we might assign an address there as well. But in general, this address scope is limited to within the fabric. There are very few cases where you would expose this to your corporate routing space. You really should never. So by default, it's a /16, right, which might be a lot. But again, this is limited to the ACI fabric. One of my good friends, coworker, tends to say is what you should do is you should just find out what your VoIP subnet is and make your infra pool your VoIP subnet, right? Because your APIC will never talk to your voice devices. One difference here is that something like your vCenter, right, that is something that your APIC will talk to. And the APIC is running Linux. It has a routing table. So this entire /16 will point towards the fabric, and everything else will have a default route pointing to your management interfaces, right? So you want to make sure that your vCenter or anything that you're integrating with ACI doesn't fall in the subnet. The next thing is our infra VLAN. So our infra VLAN is the VLAN that the APIC uses to communicate to the leaf switches. This is really important because you can't change it. Once you set up your fabric, it will stay at that VLAN unless you start from scratch again. So what we recommend is to make this 3967. So on Nexus switches or on Fabric interconnects, or even on Catalyst devices, we have reserved VLANs, right? So those are VLANs that you just can't configure on that device. And you don't want to find out that for some reason you picked a VLAN that's reserved on a switch. So from what we found is that 3967 is the highest VLAN ID that is not reserved on any Cisco devices. The next thing here is our multicast group. So the multicast group, again, is something that is, in most cases, is limited to your ACI fabric. It is what we use to flood traffic. So you can leave this at default, hit enter, move on. The next big important thing is the IP address for your APIC. So this is how you'll actually access your APIC, right? Those are those copper ports connecting to your management switch. And again, this is different from your SIMC, right? So that's a second address that you're assigning to your APIC. And each APIC will have a unique IP address. So throughout this session, we have a couple of these planning slides. And what our goal is to sort of give you a heads up on what are the different things that you might want to consider. And Joey and I put some notes in here for what we think you should consider from what we've seen in the field, what worked, what didn't work for people. OK, so going through our checklist, right, we've racked our APIC and our switches. We've configured SIMC. The next thing is management. So how do I manage this APIC? We've talked about it. It is done through HTTP. It's not the only way to manage your APIC, though, right? We've talked about the API. So I was talking to a customer once who was standing up a data center on the other side of the world, and I was asking him how long it takes. And he was like, well, it takes me about 3 months to get a fiber connection and to get everything physically set up. But once all the wiring is done, it takes me 10 minutes to configure the entire fabric because we've scripted the whole thing. So that was pretty amazing. I will say that most of our customers don't do that, right? Is you can set up everything through the APIC, but we expose that API for you if that's how you want to do it. And last, you can also SSH to the APIC. So you can go directly to the APIC. We have a limited command line. It's good for troubleshooting. You can also configure things. We always recommend that you use the GUI, though, right? So ACI is sort of built for a GUI. We always do things for the GUI first, and that's how you get the best experience with ACI. It's how we always recommend everyone learns ACI. So when you're setting up your fabric, you have to configure the management addresses for your APICs, but also your switches. So to manage your switches, we still have console. Console is still important, right? You never want to have to use it. But if this is a remote data center and your switch crashes, right, and the TAC engineer says, hey, I can't tell you what's happening without console, it's nice to have this set up. If you sit right next to the data center, maybe not as important, right? You can walk in there. You can give each switch a management address, right? So I said these are Nexus 9000 switches. They still have that copper management port on each device, and you can just connect this to a management switch, assign an IP address to each leaf switch or spine switch, and SSH to those directly. If you don't want to do that, well, you can jump to the APIC, right? You can SSH to your APIC's management address, and since the APIC assigned all our leaf switches an IP address, you can jump from there. All of this works. It's still nice to give them a management address because if you do that, you can also use the API, right? So if you want to maybe find out what VLANs do I have deployed on this switch, or what are some interface statistics, you can use the API to query that information and get that from each switch specifically. But again, as you're setting up your fabric, configure management addresses for each device. The question here.
On the switch, if you SSH direct to a switch and you make some configuration changes, does it sync back to the APIC?
Great question. So the question was, if I SSH to my switch, make some configuration changes, does that sync back to the APIC? And the answer is you can't make changes on the switch. So we have locked it down. It's a slightly different version of NXOS that we're running on these leaf switches and spine switches. It's still NXOS, but all configuration changes have to come from the APIC. OK, does that answer your question? Cool. NTP. Please set up NTP as you're configuring your fabric. This is really important, right? So you might have a fabric that has 200 or 400 switches in them. They all need to have the same time. So the first reason for this is that the APICs actually timestamp messages that they exchange. So it's important that those are in sync. We also use certificates. So if your certificates are out of, or not, if your time is wrong, your certificates might be invalid because it's before the time the search started or after the time the search started. So you'll have issues because of that. If Joey or I have to do RCA work, right, let's say something happened in your fabric and we're trying to figure out what went wrong, we're going to use tech supports. Well, you can't actually collect tech supports unless you have NTP configured, right? These tech supports are useless to us if the time is different on each switch. So really important to have that set up. One more reason to do it is we have a troubleshooting feature called atomic counters that Joey will talk about, and atomic counters rely on the switches having the same clock. So just one more reason to do it. After you configure NTP and you have the Gen 2 switches, which I probably assume most people have at this point, you can configure PTP. So Precision Time Protocol, we actually timestamp each packet, and we can see what the latency was for this endpoint to talk to this endpoint on a different leaf switch, or in general, what's the latency when it's going from this leaf to another leaf in the fabric. So really helpful, useful to have NTP configured. Next, AAA. So AAA is really important because you need to know who's making changes, right? I feel like we always talk about this in our session, and then I get on a WebEx with a customer, and his name is admin again. And I'm like, all right. There are a lot of admins out in this world. So when you log into your Fabric, it's really easy to see, hey, what are my permissions, right? If you want to do RBAC, you can just click on your little user icon, click on View My Permissions, and see what it is that you can do. If you don't feel like implementing RBAC, just give everyone a unique username and give them admin rights. We can at least still know who did it. The reason why this is helpful is because I have to share a network with Joey, and whenever it goes down, I can go in here and I can see who made a change, and it's always Jay Rastain taking down my network. But this is super helpful. One other reason here is, and this is not for like, hey, somebody caused a network outage. I've been on plenty of calls with customers where they have something configured, and like it's fine. There are use cases for doing this, but it might not be the most common way to do it, right? And you ask them like, hey, why did you decide to do this? You know, do you need to do it? And the answer is like, I don't know, right? I'm just managing this network. Well, then you can go in and you can see who made that change, right? Who configured it this way? And we know who to talk to understand if this was done on purpose or if this was more of a mistake. So it's been super helpful, really great for TAC engineers if we can figure out who made a change, talk to them, understand why it was done. Okay, so we have configured all this stuff, right? It would be a shame if we lost our configuration. So after you have done all your groundwork, please set up backups. This is super easy to do in ACI, right? You go to your APIC, you say, I want to do a backup. You set a scheduler. You say, I want to do this every day, and then you can set a destination that you want to send it to. So here we just have an SFTP server that we send our backups to. Now, one thing that is really important here is also this AES encryption setting. So there are some passwords that your APIC will store, and we want to be able to back that up, right? But if you don't give us a key to use to encrypt this backup, we can't back up your passwords because we're not going to do that in plain text. So configure your key, write down what your key is, please don't lose it, and then just set up backups and let those run. One other helpful feature here is snapshots. So what are snapshots? Snapshots are basically a way for you to say, hey, what's the current configuration of my fabric? I'm about to implement a change. So let me take a snapshot. Let me go do my change. And let's say things went downhill. We can revert this. Or we can actually just use the diff feature to say, hey, in this maintenance window, we were supposed to make these changes. Let's compare our snapshots to make sure that things that we wanted to change were changed properly. OK, so I think we had one question here.
It was about the backup, actually. Does it take backup from the Epic policies, everything, or is from the switches? What is?
Great question. The question is, do we take backups from the APIC configuration or the switches as well? And I will refer you to the WebEx team space, because by default, the APIC just does or the backup just backs up the APIC and nothing about the switches. But my dear friend Andy over here, he built a state checker app that actually compares state on all the switches as well. So what VLANs do I have deployed, and sort of what we call them concrete objects, what exists on the switches. And he will diff that for you and say, hey, you made this change. Do I still have my routes? Do I still have my VLANs deployed? Does everything still look the same? So he can probably provide some information on that. OK, so we have done our groundwork. So now let's get to the fun stuff, the fabric and tenant policies. So throughout this session, we came up with this little theoretical network here. We have a small fabric, 2 spine switches, 4 leaf switches. And what we want to do now is configure 2 VPC domains, right? So we figured we'll have a VPC domain between leaf switches 3 and 4, leafs 1 and 2. And we have our current core network, which is a 7K, and we have a server connected to that. And what our hope is going to be is to run a VPC down to the 7K, run a VPC down to that server, and have layer 2 connectivity through our ACI fabric. How do we go about doing this? Well, to set up the VPC, super easy. You don't need to run to the data center. You don't need to run a keep alive. You don't need to run a peer link. You just tell the APIC, I want these 2 switches to be in a VPC, and that's it. We will use the fabric connectivity for the VPC switches to synchronize, to communicate. So we have a protocol that we use to synchronize endpoints and different configuration parameters between the leaf switches. That used to run over your peer link. Now it's a TCP session that goes through the fabric. So all you need to do is go in here, say, hey, these 2 switch pairs should exist. I want them to be VPCs, and we have created our VPC domains. The next thing we need to do is create our VPC port channel. So in ACI, we have concepts of policies, which means we have policy groups as well. So this right here is a VPC interface policy group. And this is where I can configure different characteristics of this interface, right? So one example here is, do I want CDP enabled? MCP is a sort of loop prevention mechanism or error disable mechanism that we have in ACI. LLDP, do I want LLDP on these links? And then this is a port channel, right? So please use LACP mode active. But this is how I would basically configure my port channel, right? I now have to map this back to a physical interface on a leaf switch and point that to a switch that I want to deploy it on. But this is what I would use to create a VPC port channel, right? So what have we done so far? Well, we've created our VPC domain. We've created our port channels, which means we can move on and go to our tenant policies, because what it is that we want to do, right, is extend a VLAN from our legacy network to this test server that we connected to our fabric. Tenant policies, there is a lot of new stuff. So everything is going to be a tenant. A tenant, in a way, is just a folder that contains configuration for something. A tenant contains a VRF, and luckily a VRF is just a VRF, so there is nothing new here, right? It is a unique routing space that will exist for this tenant. Now, a tenant will map to a bridge domain. And a bridge domain is where things in ACI start to be a little different from what you're used to, right? So a bridge domain is our broadcast or flood domain. It's our layer 2 forwarding boundary. Is a unique VXLAN ID, right? So we extend a bridge domain through the fabric using VXLAN. And we can configure different things on our BD, like ARP optimization or how we want to handle unknown layer 2 unicast flooding. Last, I can also define a gateway on my bridge domain, right? So I can say, hey, for this bridge domain, let's call it bridge domain VLAN 100. I will configure gateway address 100.1. So this bridge domain ties to an EPG, an endpoint group. And this is really the new thing in ACI that you have to wrap your head around. But let me talk about what sort of the high-level idea behind an endpoint group is. So it is a place where we can define a collection of policy, right? So a group of servers that are supposed to behave the same way in my network, why do I have to configure each interface that those servers connect to? Why don't I just configure my endpoint group, right? So an example here could be, what are the QoS requirements of this server, right? Let's say it's latency sensitive or something like that. I apply the QoS configuration to the EPG. I might also have span requirements, right? Let's say this is a externally facing web server, and the security team comes to you and says, hey, anywhere where you have a web server or web VM connected, I need you to span the traffic to my ER-span destination, right? So instead of going to each leaf switch and implementing that configuration everywhere, you just tell the APIC, hey, any server that's part of this grouping, this endpoint grouping, span the traffic for me and apply these QoS parameters. We can do other things like L4 through L7 policies. So if you want to insert load balancers or firewalls, you can do this on the EPG as well. We can do contracts. I'll get into contracts next. Those are basically just access lists, right? Who do I want this group of servers to be able to talk to? But most commonly, what an EPG really just is a VLAN and a port. So my bridge domain, which is my layer 2 forwarding boundary, ties to an EPG. And when I go to my endpoint group, I say I want to extend basically the bridge domain using this VLAN on this specific port. So that is what an EPG really becomes, and we'll go into that in a second. Contracts are really important, right, because this is new in ACI. A contract is used for me to be able to say, endpoint group client can communicate to endpoint group web using port 80 and port 443. We have a concept of a provider and consumer. That basically just replaces the source IP and destination IP statement when you're creating a traditional access list. But within your contract, you have filters, and that is exactly what you're used to from access lists, right? So basically what we have done is we have gone away from using source and destination IPs to identify the servers that we want to apply policy to. We just say, hey, if the server is part of this endpoint group and it wants to talk to this endpoint group, we will allow these filters in between. What does this look like in my GUI? Well, when I go to my tenant tab, I have my application profiles folder, and that contains my EPGs. So there's something called network-centric migrations or a network-centric deployment. You have probably heard of this. It basically just means if I had VLAN 100 in my legacy environment, I create a bridge domain for VLAN 100, and I tie that to an EPG using VLAN 100. And remember how I said the most common use case of an EPG is to just say, extend this endpoint group on this port using VLAN 100, right? So that's all we're going to do. I then have my VRFs and my contracts. So let's go back to VRFs. What is important on the VRF? Well, the VRF is our policy enforcement boundary. So you can decide that you want to use this model of contracts and this whitelist model on a per VRF basis. If you don't want to do that, you can set this to unenforced. If you have questions about this, feel free to come talk to us. I think a lot of people have opinions on this. My opinion is always to leave your VRF in unenforced or in enforced, sorry about that, and just use a permit any contract to simplify your deployment. We then have our bridge domain. So for our bridge domain, if you want to keep it simple, you just call it what you'll be using it for, right? So a VLAN in your legacy environment is a layer 2 boundary. A bridge domain is a layer 2 boundary. Let's have a one-to-one mapping between bridge domains to VLANs. You never really want to have one bridge domain connect to 100 VLANs in your legacy network, right? You typically want your layer 2 boundary in your legacy environment to equal a layer 2 boundary in your ACI fabric. I can also configure some forwarding characteristics, and we'll dive into what we have there, but we can optimize what we do with flooded traffic, and that's all done on the bridge domain. When it comes to the EPG, this is the static port that I talked about, right? So here I have an EPG called VLAN 100. It is tied to bridge domain 100. And if you remember that VPC that we created, right, it was called N7710 VPC. So this is my VPC going to my 7K. I'm extending VLAN 100 down to the 7K. So what have I done with this? Well, I have now, if I do the path to that server as well, I've created a layer 2 path through my ACI fabric under the covers, right? We've used ISIS and VXLAN to do this for you. But you as the administrator, you don't have to care about that, right? You're just going to say, hey, on the 7K, I have VLAN 100. It's a unique layer 2 forwarding domain. So let's keep it that way, right? Let's create BD 100 in ACI, and we'll use an EPG to represent all servers that exist in VLAN 100. OK, let's say I now have a lot of servers connected. Do you really want to go in and create all these static paths manually, right? If you have an ESX cluster of, let's say, 100 servers, and you have all these different VLANs that you want to deploy on there, you don't necessarily want to click through the GUI this much, right? So we can optimize this for you, and it's called VMM integration. So we always use VMware as an example. It's not the only thing you can do, right? You can do SCVMM, you can do open stacking, you can do all sorts of VM or virtual machine or container integration. But the way this works is that the APIC is going to talk to the vCenter and say, hey, I would like a distributed virtual switch, please. So the vCenter creates a distributed virtual switch. You have to go in and you have to add your ESX servers to that VDS. And when you do that, when you attach your hypervisors, you give it a physical NIC, right? So through LLDP now, this ESX host will figure out where in the fabric am I connected to the leaf switches. Tell vCenter, and vCenter will go ahead and tell the APIC. So in ACI now, we have our beautiful application profile, right? Our web app and database layer. And we're going to say, hey, we would like these to be VMM enabled. So when we do that, we push, or we tell vCenter that we want a port group that's called web, app, and database. So if you're familiar with vCenter, we have a concept of port groups on top of our distributed virtual switches. So this is all cool now. And now our VMware guys can put a VM into one of these distributed port groups. So when they do that, vCenter alerts the APIC and says, hey, a VM was just booted in EPG web on this physical host. Well, the APIC now knows exactly on which interface this host is connected. It knows what EPG it's in, so it can just push the configuration, the EPG, the static path for you automatically. All right, so that is how we do our static paths, but now let's say we want to take it a little further, right? Probably the end state that we want to get to is that our leaf switches connect to our campus core or core network, and the ACI fabric is providing layer 3 connectivity for the servers that are inside of it. So how do we do this? Well, within our tenant, we have to create something called an L3 out. I think we actually call it an external routed network in the GUI, but you will hear everyone refer to this as just an L3 out. So what is an L3 out? This is where we can configure a routing protocol. So in this example here, I love to use OSPF, but you could use BGP, you can use ERGRP, and just like you'd configure a router, right, you have to tell it what area do I want to be in, what type of an area is it. I would then go a little further and I'd configure my IP address that I want to use for peering. But at the end of the day, what I will do is I will configure a OSPF peer to my core network, and I will learn the routes that exist in my campus. The leaf that you deployed the L3 out on will now become a border leaf. So any leaf that runs a routing protocol that connects or extends the network to an external router, we call a border leaf. And what these border leafs are responsible for doing is taking the routes that we've learned through OSPF and redistributing them into BGP. And our spines are route reflectors. So the border leafs just tell the spines, hey, we learned these routes. Can you please make sure everyone else knows it? And the compute leaf will then learn the routes through BGP. Why is this important? Well, in the small network of 4 switches, right, we probably could have just run OSPF on all of them, but as we scale our fabric to 200 or 400 switches, we don't want to run OSPF on 400 switches. So how do we do this? You have to be an expert in BGP and all of that. So you go into ACI, and all you have to do is give it an AS number and tell it which spines you want to be a route reflector. So that is all of that needs to be done. If we want to take routes that we have learned from, let's say, OSPF or ERGRP and redistribute them into BGP and make sure all other leafs that have this VRF deployed on them know how to reach those external routes. On your leaf switch, right? So if you SSH to your leaf switch, we still have the NXOS command line. All of this still exists. And if you did a show IP route for your VRF, you would see that we have learned the default route and that 10/24 network through BGP, but via overlay 1 from these 2 switches. So if we figure out what those 2 switches are, those are our border leafs. So this is BGP, VPN, v4. It is a really easy way for us to redistribute all routes from your campus network into the ACI fabric. OK, so this is how we would go about really extending layer 3 connectivity to your core network. Do we have any questions so far? One question right there.
Everybody over here is trying to download the slides, and we can't get them. I see one person up there in the front row had the slides, and if you go to that website, you can't get to that one, and it just, the agenda page is all that's up there.
All right, I don't think that's ours. So, question about the slides. If you open up the WebEx team space and there's like a little button, looks like a menu button, you click on that and it should have files. It's just the agenda. Yeah. Yeah, so the app, when you say the app. Oh, the Cisco Live app? Okay, so the Cisco Live app, if you go to the session, you should be able to download the PDF from there as well. If not, please come talk to us after this, and we'll make sure you get that as well. We had one more question over here.
Border leaf, can you have L2 and L3 on the same border leaf?
So the question was, on a border leaf, can I have layer 2 and layer 3 connectivity? And the answer is yes. So you can peer using an SVI, and if you do that, well, I can still trunk layer 2 bridge domains, right? So that is possible. Or I can have a routed port, routed subinterfaces, and then just use a different physical port to extend layer 2 connectivity. All of that works. One more question over here. Question about transit routing. So question is about transit routing in ACI. It basically means I have 2 separate layer 3 networks connected to my fabric, and how do I go about redistributing routes? In this session, this is an intro session, we will not get into it. There is a L3 out troubleshooting session coming up by Takya, and he will do an awesome job of literally explaining to you everything that you need to know about that. So I'd recommend you on Thursday. Yeah. Okay, so we've talked about what we need to do. I have about 10 minutes left. So we just wanted to do a quick forwarding overview, just high level, how does forwarding work in ACI? How is it different, so you understand it, before Joey will go into our migrations. So we use the term endpoint a lot. I never used that on DC switch. It was a MAC address and ARP entry. But what is an endpoint? Well, it's really a MAC address and an endpoint. So in a traditional network, right, if you wanted to find out where a server is connected, you'd SSH to the gateway for that server. You'd run show IP ARP. You'd get the MAC address, run show MAC address. You'd see that it's connected on a port channel going to a different switch. Or you run show CDP neighbor. And hopefully it's not too many layers. And finally, you figure out where the server is connected, right? Well, in ACI, you SSH to your APIC, and you can just type in show endpoint IP, plug in the IP address that you're interested in, and you will find out, hey, this is the MAC address of that endpoint. It's connected on node 101, interface ETH11 using this NCAP. So this makes it super easy, right, to figure out where things connected. If you need to troubleshoot anything, you can go to your APIC command line. I will also say you can go to your APIC GUI. I think throughout these sessions, we're doing a couple different ACI sessions throughout this week, and we always try to decide between using the command line or the GUI, and you can really, in most cases, use both. So if we ever show you something where we show you the command line and you're thinking, oh, I wish I could use the GUI, well, that is typically possible as well. We can also do it from the leaf switch, right? I really want to focus on this and make sure that everyone remembers that we have a command line on the leaf switch. So if you are used to troubleshooting a Nexus, and that's what you know how to do really well, well, this is still a Nexus, and we still have a command line. As TAC engineers, this is where we spend our time. We go to the leaf switch, and that's where we do troubleshooting, right? So I can also run show endpoint for a MAC address, let's say. And again, an endpoint is the combination of the MAC and the IP if it exists. And you'll see both of them. If you add this detail keyword, you'll even see the endpoint group that this server is in. OK, so where is ACI a little different? And it starts with ARP. So ACI leaf switches, we will learn off of ARP. And what does this mean? Well, it means when a server sends an ARP request, right? Let's say this endpoint wants to talk to endpoint 2 over here. Our ASIC is going to look at that ARP request and go, oh, hey, look, sender MAC is this MAC address of this server. And the sender IP address is 192.168.1.100. So the cool thing about this is that we do all of this in hardware. So we don't need to invoke the CPU, right? We don't need to go through some sort of glean process or something like that. An ARP request comes in. Our ASIC says, hey, as an FYI, this is the layer 2 and layer 3 identity of this endpoint that's connected on this port, so we now know where it is. When it comes to IP learning, we only do this when unicast routing is enabled on the bridge domain. So on the bridge domain, one of the options that you have on top of specifying how you want to forward certain traffic, you can also turn off or on unicast routing. And when you have unicast routing enabled, our ASIC will look at the sender IP address to figure out the layer 3 identity of that endpoint that's attached to the leaf switch. We do the same thing for routed traffic, right? So here, if the fabric is acting as a gateway for a server, and it sends a packet to our gateway MAC, to the bridge domain defined gateway MAC, our ASIC is going to say, hey, well, if he's trying to talk to something off subnet, I'm sure that device is going to respond back. So let me just look at the source IP address and learn in hardware the layer 3 address of this endpoint attached to my leaf switch. Again, this would only happen if I had unicast routing enabled. So why does all of this matter? It's really important because we can do something called proxy routing, right? So what do we do when a leaf switch learns an endpoint, when it learns the layer 2 and layer 3 identity of an endpoint? It is going to report that information back to the spine. So we learn an endpoint. The leaf says, hey, let me publish this to, it's a process called coop. Let me publish this to the spine and tell the spine that this specific endpoint is connected to me. The spine will now synchronize this with all other spines that you have in the fabric and install that entry in hardware, right? So if you remember how a modular chassis is built, we have our line cards, and then we have fabric modules that interconnect these line cards. Well, what we decided to do is to actually put some knowledge on those fabric modules. So across all the fabric modules in hardware, we can install, I think it's up to 1 million endpoints in hardware. So we have the table capability to have 1 million endpoints in hardware, and with that, we can do some cool stuff. So here on this bridge domain, I have unicast routing enabled, and I have ARP optimization enabled. So when I have that set, and I receive an ARP request on my leaf switch, I would first of all learn the layer 2 and layer 3 identity of this endpoint. But then I can look at the target IP address. Again, this is all the ASIC doing it, right? The ASIC looks at the target IP address and says, do I know where this server is connected that is being ARPed for? Do I know the target IP address? And if the answer is no, it's going to send a unicast frame to the spine, to the proxy process. And in hardware, the spine's going to say, OK, let me send this down to the fabric modules. We'll do a lookup. If this endpoint exists in ACI, the spine will know where it is. So we'll do a lookup and say, hey, you know what? That endpoint is connected to leaf 3. In hardware, it will forward it to leaf 3. Leaf 3 will get it. It'll look at the target IP address and say, hey, OK, this is destined for this specific server. Let me send it to just that device, right? So this is really powerful if you have a large layer 2 domain. We no longer have to flood an ARP request to every single port that exists in the VLAN. But if that is the sort of thing that you like to do, or we find that a lot of customers have legacy applications that rely way too much on ARP, it's not a good thing, you can just enable ARP flooding. So what do we do when ARP flooding is enabled? Well, here an ARP request comes into our leaf switch. Our leaf's going to look at it and say, OK, well, I don't have ARP optimization enabled. This is a broadcast, so let me flood it locally. But let me also encapsulate it in a multicast packet this time. So if you remember, when we first set up our APIC, we had to give it a multicast group. So the APIC is going to use that multicast group to assign a multicast address to every single bridge domain. So this packet came in. The layer 2 forwarding boundary is the bridge domain. It's mapped to a multicast address. We send it to the spine. And the spine, through multicast, knows every single leaf switch that has this bridge domain deployed on it. So we can make sure only the leaf switches that have this BD deployed get the ARP request. The remaining leaf switches will just flood it out their local ports, just like a traditional network would. OK, moving towards more traditional unicast flow. So when we're going to talk about unicast, we have to talk about the Anycast gateway. in ACI, we will push the gateway address, right? So that's the subnet address that we configured on our bridge domain to every single leaf switch that has this bridge domain deployed. So we're no longer limited to maybe we had VPC in the past and we would run VPC active, right? And that was really cool. In ACI, we do this on every single leaf switch. We will put the gateway address on every single leaf switch that has the bridge domain deployed. So we wouldn't have to switch a packet through the fabric to get to a leaf that has the gateway address defined on it. So this gives us deterministic traffic flows and consistent latency when going across the fabric. So here, we've defined our gateway on our bridge domain, and we have 2 servers in 2 different endpoint groups attached to 2 different bridge domains, and they want to communicate, right? So we receive, let's say, a ping, server 1 ping server 2. We receive an ICMP request. We do a lookup, and let's say it's known, right? So we know that we need to send this packet to leaf 3, and what does the leaf switch do? It drops it. Why does it drop it? All right, not enough information here. We'll work on that next time. The reason is we're missing a contract, right? So now we're going between 2 different endpoint groups, and depending on how we set up our VRF, we can now utilize contracts to say, do I want this endpoint group to be able to talk to this endpoint group, right? If it's web and app, yeah, sure, I might want that to happen. I might put a filter in there. But if it's really just 2 different groups of servers that should never be able to communicate, why give them the ability to communicate, right? We can use policy enforcement in ACI to very easily say, hey, should these 2 devices be able to communicate, yes or no? So we add our contract, and now our traffic flow will work. I should also say, if you're ever troubleshooting this, you can just go to your tenant. There's an operational tab, and it will show you all flows that are being dropped because of contracts, right? So make it really easy for you to figure out, hey, am I missing a contract or not? We got a question over there. Yeah, so the question is, they're in 2 different bridge domains, but in the same VRF. And can they not talk because they're in the same VRF? And yes, the reason is they cannot talk because by default, it's a whitelist model in ACI. So we have to say we want these devices to communicate. Now, when you configured your VRF and you say, I don't want to use this policy enforcement, you make the VRF unenforced, then these devices would have been able to talk without even thinking about contracts. So both is possible. OK, cool. So we've talked about why ACI, infrastructure and policies, a quick forwarding overview. So this is a great time for Joey to come up here and talk to you guys about how you go about doing a migration.
Test. Hello? Great, you can hear me. Thank you, Carlo. How's everyone feeling? You guys experts yet? Oh yeah, you guys feel great, don't you? Awesome. Well, before we get going into the network-centric migration portion, just a quick intro about myself. My name is Joe Restaino. I am indeed friends with Carlo, despite some things you may see in these upcoming slides, some changes he may have made. However, we were great friends. It was great when he came over to the team because we could really leverage each other's knowledge. He had a lot of knowledge in switching. I came from a UCS background, so I had more knowledge in compute and VMware and things of that sort. So to be able to tag team the session today with him is great, and hopefully we can roll off some of that knowledge on you today. So after the UCS team, I went to the ACI team for a while, and now I'm in the BU escalation team for ACI. So if the TAC ever has any problems that they need additional triage on, they may contact my team, and we help to root cause those problems, and more importantly, follow up after the fact and figure out, how did it get to this point? What can we do to fix it in the future, and really focus on serviceability. So with that being said, let's talk about network-centric migrations. Now, it's very common that you purchase ACI equipment and you do not, it's not a greenfield deployment, right? You have these additional networks. We've been harping on this the entire time. We have the 7K. We're trying to get traffic into ACI and to my endpoints in ACI. So it's very common that we have to migrate services, and in most cases, have those services communicating for a long period of time until they can be decommissioned. So in order to do that successfully, we highlight what's called the network-centric migration. We're going to dive into what that means. But essentially, in order to accomplish this, we need to have some foundational things set up. We need a physical topology that will allow us to have this. And what we're going to do is we're going to leverage a back-to-back virtual port channel between this core distribution and aggregation topology connected in the distribution, where we have a loop-free topology now because we're using VPC, but we also have a lot of redundancy. We have, these could be 40 gig links here, and we have 4 of them. So redundancy, bandwidth, but also loop-free. Well, Carlo talked about the policy groups, so that was easy. Okay, moving on. So in order for us to start with a layer 2 migration, what are we going to need? Well, there is, by definition, something in what's called the network-centric migration, and that is a unique VLAN equals a unique EPG equals a unique bridge domain. So Carlo kind of highlighted that. So what are we doing? Well, we have this traditional environment, and it has VLANs, and there's traffic in these VLANs. What happens if an unknown unicast frame comes into that switch by default? It gets flooded, right? What happens if an ARP comes into that switch? It gets flooded, exactly, right? So we need to ensure that the ACI fabric is going to do the exact same thing. Because while these things are talking to each other and while they're operating together, they need to have the same forwarding constructs to ensure we don't have any silent host problems or we start dropping traffic because it's not being flooded properly, right? They should be configured the same way. So what we're going to do is for every VLAN that we're going to be extending from our legacy environment into ACI, we're going to create a unique bridge domain. And we're also going to enable flooding on ARP and on unknown L2 unicast. We're also going to make sure that routing is disabled. We're going to enable routing when we talk about layer 3, but for now, we have no routing capability in ACI. We're simply extending layer 2. After that, we're going to create a unique EPG for that corresponding VLAN, and we're going to associate to that endpoint group the bridge domain. Now, if you can see here, I'm using a naming scheme that I personally like. I have VLAN 100 on my external network. Now I need to create these network-centric constructs, this EPG and this bridge domain. Well, if you name them VLAN 100 and you create a one-to-one mapping, it becomes very easy to understand that the traffic in this bridge domain, the traffic in this endpoint group, is going to correspond to VLAN 100 on my legacy network. So I typically recommend to customers that you give it some type of naming scheme where you can easily identify the VLAN that we're associating to this network-centric deployment. And then again, what have we accomplished? We have a one-to-one mapping now, so that's great. Now that we have this configured, traffic can flow across the ACI fabric. It can then get switched locally in either site. And if traffic needs to go to its default gateway, it can go across to the legacy environment where the gateway still exists and then get routed. So all we've done is extended layer 2. If traffic needs to get to the gateway, it'll still go across to your traditional environment and get routed from there. Right. Question? Great question. So the question was, am I forwarding in the EPG or am I forwarding it in the L2 out? So there is a concept of an L2 out versus just extending the port in an EPG. Okay. For this particular case, I'm using the EPG. Okay. So what I'm doing is on the EPG, I'm saying, hey, on the port channel that goes to my legacy environment, I'm adding VLAN 100 to that port in the EPG as a static path binding. I'm also doing the same exact thing for my servers in this EPG. So there is a concept of a layer 2 out. We are not going to talk about necessarily the differences or the scope of the session, but you can find plenty of material externally on the differences of that. But for a network-centric deployment, I'm extending it simply under the endpoint group. Does that answer the question? Great. Okay. So now we're going to start seeing our fabric kind of come alive a bit because we've extended our VLAN, and guess what? Packets are coming into our bridge domain. They're getting classified with the policy under the endpoint group. So we can go under the endpoint group now, and we can essentially look at our MAC address table, right? So Carlo did a good job of highlighting with the APIC now, we have this really cool single-stop shop where we can go and see all of the endpoints. We no longer have to go hop by hop and check the MAC table and check the interfaces. The APIC gives us that power, and it can do it on a per EPG basis. So if you're troubleshooting something and you're like, hey, I need to see if this flow, why it's not working, well, go to the EPG and see if you're learning the MAC addresses, right? That'd be a good place to start, because if you're not, you probably don't have that VLAN configured on that port, or there's some other issue. Perhaps there's a fault on the endpoint group, right? We can use these things to help troubleshoot why that may happen. Okay, so we've done layer 2. What about layer 3? So in order for us to now move the gateway from the legacy environment into ACI, we need to do a few things. And the first thing is going to be configuring that layer 3 out that Carlo talked about. Right? He mentioned that we support multiple different protocols. We support OSPF, BGP, EIGRP, all the things that we would want. And we also support, as far as the physical connection to do this, routed subinterfaces, routed interfaces, or SVI. So it goes back to that gentleman's question about, can I do layer 2 and layer 3 on one border leaf? Right? You can. If you used an SVI, now you can peer with an OSPF neighbor using a VLAN, and then you can use the other VLANs that you haven't already used on that same interface for EPGs, right? So that you can accomplish that. So we configure an L3 out, and then we need to make some settings to the bridge domain to enable routing functionality. So we now need to say, hey, I want to do unicast routing. That's one checkbox. We'll go ahead and enable that. Now I need to define a subnet. So what am I doing when I define a subnet? Well, Carlo mentioned in the forwarding section about the Anycast gateway, right? We configure an IP address. That IP address will be used as the Anycast gateway. So what is that doing? The APIC is going to push this subnet, or SVI, right, to every leaf that has a device connected in the bridge domain, automatically for you. So you no longer have to worry about going to the switch, the gateway, enabling that, and then making changes on a ton of different switches depending on your environment. The APIC will dynamically enable that SVI on every leaf where those hosts connect. So very, very powerful. And it's an Anycast gateway, so it's always directly connected. We now need to say on the subnet, or the bridge domain rather, which L3 out do I want to associate this to? Because what are we going to do? Well, we want to advertise this subnet, this Anycast gateway, out of some type of routing protocol that we've configured on the L3 out, right? In order for us to do that, we have to tell it which L3 out we want to advertise that with. So we have to make that association. Now, finally, we need to go to our endpoint group that matches to the corresponding bridge domain. So in this case, I have VLAN 100 EPG. That would be bridge domain VLAN 100 if we use the naming scheme that I hope you guys took my recommendation on. We need a contract. Now, why do we need a contract? You're like, hey, you talked about these EPGs. You talked about how you need contracts between them. Now you're talking about this L3 out. Why are you talking about contracts? Because every L3 out you create is still an EPG. The way we do the classification is a little differently because we do classification based on a prefix, but it's still an endpoint group. So if you do not have, if you've disabled policy enforcement on the VRF, this wouldn't be required. But if you've enabled policy enforcement, then you need to make sure that the EPG has an association to the L3 out in the form of a contract. And when that happens, the subnet will get advertised, into our routing protocol, either OSPF, EIGRP, or BGP. If you're doing static routing, you can just do a static route. But. Question?
Are there any limitations on dynamic routing? Do you have the same options for OSPF, EIGRP, BGP as you would on a BSR?
Yeah, so the question is, what options do we have when it comes to configuring these protocols? What nerd knobs, I guess? Like, what things do we support? We do support a lot of options when it comes to L3 outs. Each individual protocol has its own policies. So if you wanted to do maybe a broadcast type domain versus a point-to-point OSPF domain, that's a policy, and that's grouped under the OSPF config. If you wanted to do many BGP knobs, that would be its own BGP policy. But to answer your question, yes, I would say as far as an enterprise routing platform, we may not support as many, but we support plenty of knobs that you can configure and customize in many ways. Okay. So now, what are we going to do? Well, we're going to now take the gateway from the legacy environment, and we're going to move it to ACI. Right? We've enabled that subnet. We've enabled routing. We've associated the contract. And finally, we've tied that to the L3 out. So now what happens? Well, traffic can go to the ACI fabric and get routed if it wants to stay locally in the traditional network. Traffic in ACI can get routed locally because the Anycast gateway provides us that routing functionality. We can send traffic between EPGs in both VLAN 100 and maybe VLAN 101. So we have routing across the entire platform. And then if we want to send traffic to our L3 out to go to our core, we can send it to our border leaf, and that traffic will then leave the fabric. Because we've created that L3 out, we are advertising routes, we're exchanging routing information. We have reachability in the fabric as far as where that traffic needs to go. So, Joe, this all sounds really easy. Are there any considerations when migrating to ACI? Of course, there are considerations when migrating to ACI. Right? Carlo did a pretty good job of highlighting how we're doing some new learning functionality when it comes to ACI with ARP and how we do routed traffic. So we're going to talk about some of the considerations there. The first consideration, though, and I'll say this twice. I'm going to say it the first time, so I'll be brief. We have to make sure we disable the external gateway. Right? I don't think I need to explain in detail to any of you in the room the ramifications of having a duplicate IP address. Right? A duplicate IP address that's also your gateway. Doesn't sound like a good thing. So we want to make sure that we disable that, and then we enable the subnet under the bridge domain. The next thing to do would be, well, cool, now we have all this routing functionality in ACI, so can I now enable all those cool knobs in the bridge domain that allow me to optimize forwarding? Because you had me configure it all for flooding to match the traditional environment, but then you spent 10 minutes talking about how we can optimize ARP and optimize unknown unicast. Well, can I do that? Of course. But there are some considerations when doing that. So when enabling unicast routing, what are we doing? We're defining a subnet. That subnet is going to become the new gateway for these servers, right? So there'll be a very minor service impact because we're going to send a gratuitous ARP. The host will have to update their ARP table with the new gateway address. So there's going to be a very, very minor service impact, but still, the hosts need to get this new ARP refresh so they can send traffic to us now and not to the old gateway. When you want to go from L2 unknown unicast flooding to hardware proxy, to make use of that proxy technology that Carlo was talking about, there's a slight service impact in doing that. Now, there's a technical reason for that. And the technical reason is we have different VXLAN ID ranges that we reserve depending on the mode you're in. So if I want to change modes and I need to allocate a whole new VXLAN ID, I need to redeploy that bridge domain on the switch. So it shouldn't take too long, maybe only a few seconds, but there is a minor service impact in making that change because we do need to change the configuration on the switch. Traffic in that bridge domain will be affected while making this change. Right? We also want to ensure that we have limit IP learning to subnet configured. Limit IP learning to subnet. What does that mean? Well, we talked about our network-centric approach. Right? We have a VLAN equals a bridge domain. That bridge domain has a subnet. We probably don't expect devices in a different subnet to be connecting in this bridge domain, right? It's very important because we're keeping the same constructs that we have in our legacy environment, right? We're not doing anything crazy. So we want to make sure that the ACI fabric switch, when it receives an ARP or it receives a routed frame and it does an IP learn, that it can actually check the subnet configured onto that bridge domain to prevent the learn if it's not in the same subnet. Because someone could have a misconfiguration. There's a whole lot of things where that could go wrong. We want to make sure we have that in place. Question?
You enable that, and you have something, this IP, will it still show up like an operational tab?
Great question. So the question is, if I have something misconfigured, and it's supposed to be blocked, will I still see that in the operational tab? And the answer is no. What the operational tab will show you is what are my current learns. If we've prevented the learn because of a configuration to prevent it, then that will not show up. Now, you'll always see MAC address, right? But you will not see the IP if it falls off the subnet and you have limit IP learning to subnet configured. So the final consideration would be, well, can we just make it so that our fabric can just do this by default? Because I don't want to go to every bridge domain and enable this. Right? It seems kind of tedious. Well, the good news is in two ways you can accomplish this. One is starting in version 2.3, which is relatively old at this point. We hope most customers have moved beyond that. Anytime you create a new bridge domain, the setting is automatically enabled. Right? But if for any reason you have applications that were on a version prior to that and you haven't made these changes, you can enable what's called the global subnet check. And what this does is it enables limit IP learning to subnet globally across the whole VRF. It's actually slightly better than just configuring limit IP learning to subnet 2, because what limit IP learning to subnet does is it blocks the learn as it comes into the fabric. But if that traffic gets routed across the fabric and gets to another leaf, the leaf can still learn the IP. So now we're running into a situation that's kind of weird. We have some leafs that have it and some leafs that don't. The global subnet check prevents IP learns off subnet for any subnet in the VRF. So it's a good configuration to have. We recommend this as a best practice to all customers, especially when doing a layer 3 migration to ACI. So just like the MAC table, well, now we kind of have our ARP table, right? We can go into our operational tab, as this gentleman alluded to. Will I see it? Well, in this case, it is in the same subnet. It passes that. We do an IP learn, and we can see now the IP address and MAC association. So now you can kind of see, depending on what your config is of the bridge domain, what things do you expect, right? If you have routing disabled, you only see MAC. If you have routing enabled, you can potentially see IP as well. So. Now, for routes as well, you can use the UI, and you can go to your L3 out. In my case, I have an OSPF L3 out, and I can see all my routes. So as we learn routes dynamically for OSPF, we create objects for them, and we can populate that information in our UI. It's just an API call. So we can easily see, what things are we learning. If you want to go to the switch, you can, of course, do that as well. So I think one of the biggest misconceptions of ACI, and I think this is even something that Carlo was like, dude, I don't want to go to the ACI team, man. You have to do this APIC now. This is just too different. I want to SSH to the switch. You still can. we're running a different version of NXOS, but we still have a fully loaded show output commands you can run, show IP-OSPF neighbors, show IP route, show interface. We have all these things we support. You can still go to the switch. You can still run these commands that you already know to troubleshoot potential problems. OK, common pitfalls. Last time I'll say it again. You can't have the gateway active. When you enable routing on the BD and you enable a subnet, you are taking over the job of that external gateway. That must be disabled. But one other common pitfall would be some type of load balancing that Service introduces. For example, on Windows, there's a dynamic load balancing that Windows does. So what is dynamic load balancing? Well, what that is essentially is that on a particular interface, it will respond to ARP on only one. So if I send an ARP for a device that's running dynamic load balancing, it sends that ARP request always up one interface, right? That's great. We learn the location of the IP on that MAC. But when it sends routed traffic, it can leverage both. So what have we learned from how ACI does IP learning, right? It does IP learning based on routed traffic. So if that happens, and we start sending traffic with both MAC addresses for the same IP, ACI is going to start seeing this IP address moving between these MACs. There's going to be instability. There'll be churn in how we update our endpoint tables. It's not something that we want. It's something we want to avoid. So what would the fix be for this? Well, one fix could be you could change the dynamic load balancing config to use what's called Hyper-V port, if this is a SCVMM server. And what this does is it ties the IP address to one MAC, one interface, right? And if that interface goes down, it'll fail over. But what we're trying to understand here, or what we're trying to highlight here, is that it's not coming from both MACs, right? It's only a single MAC, and it's resilient to failover. Or another option you have is we support in 4.0 what's called disabling IP learning on the VRF. So what does that mean? It means that now we're going to do exactly what a traditional router would do, which would be it updates its IP address tables based on ARP alone. So there's no need to have this IP learning because I have these servers I have no control over, and this is how they work, and this is what they want to keep doing. I can disable learning on the VRF, and I can just rely on ARP, which we know it will only come in on a single port now. Great. Are there any questions about migration? Excellent. Oh, we got a few. OK. I saw a hand over here, and then I'll get to yeah.
So when you do the migration, how about the VLAN gets conflict with two different formats? Like let's say if I have the existing VLAN number already used in JCA fabric, when I do the migration, I get to choose the same VLAN number. How do we deal with that?
Yeah, that's a great question. So the question is, what if I've already reused the VLAN that I have in my legacy environment already in ACI? Now I want to migrate that VLAN into ACI. It's already in use. Yeah, that could be a challenge. And the reason that is because by default, a VLAN on a port defines the EPG. You can't reuse that VLAN on that port, right? There are ways to get around this. We have per port VLAN configuration. But for the most part, it would be better that if you're going to plan a migration to ACI, you definitely do not use the existing VLANs because you're going to want to migrate those seamlessly, right? If you have new applications, hopefully you have some nice way of seeing what's already in use. But yeah, you want to choose a new VLAN, for sure. There was a hand. Yeah.
So you're talking about the layer 3 migration stuff. And one thing that I had a question about is like the global setting to enforce the subnet check. Is that something you do when you're done with all the layer 3 migrations, or can you do that at the beginning? Just so I'm doing the exact same thing. I don't want to break the guy.
Great question. Yep. So the question was, when talking about the enforced subnet check globally, so not the limit IP learning on the bridge domain, but the global enforced subnet check, is that something that I'd want to do after the fact or before? It's a great question. When you create the VRF, you can enable. This is a global setting, so you can enable this globally whenever you want, right? What happens when you enable this feature? Anything that is off subnet will get deleted. If we've done a migration correctly, we should not have any off subnet. This is more of a preventative thing. So you can do this before the migration. You can do it after the migration. It's completely up to you. A lot of customers have this as a best practice when they configure a new ACI fabric from scratch. They enable this right away. Right? They don't have to worry about it. So it's really up to you. But before or after, or as a best practice, do it when you stand up the fabric even. Question.
With regard to network-centric migrations, what is your quick list of pointers when each SVI that has to migrate into the fabric involves extensive ACLs? And I'm not just talking about ACLs for east-west traffic, but extensive ACLs that involve north-south traffic to the enterprise WAN and other on-campus locations that are outside the fabric.
Yeah, that's a great question. So the question was, when I'm taking my gateway and I'm migrating it into ACI, and that gateway has extensive access lists that I've already put on there, and traffic is being enforced there, what do I do when I want to migrate it to ACI? This is a great question. And we do have products to help understand the traffic flows and how I would take an access list and translate that into a contract. Essentially, what you need to do, though, is you need to make sure that the access lists you have configured are properly reflected as contracts in ACI. That's the one-to-one mapping of what a contract is to a traditional construct. It's an access list equals contract. So if you say, hey, on this SVI, I have traffic deny port 80 or deny some other thing, for your corresponding EPG for that same subnet, you'd also have that. You'd either exclude that or you could put a contract that says denies that. So you basically want to make sure that since we're doing network-centric, we have a one-to-one mapping of EPG to BD to subnet, that your configuration on your external device matches the contract on this EPG. All right, fantastic. So let's move on. So I think it would be amiss to kind of walk you guys the theoretical first 7 days of ACI and not talk about what options you have for multiple data centers. Right? I think it's ever since data center technology took off with the 7K and OTV was introduced, it's been a huge talking point. A lot of customers have DR sites. They have active sites. And ACI has other options as well to allow you to accomplish the same thing. So want to talk about the 3 main solutions that we have that we can deploy and what some of the benefits are and what are some things that you'd want to take into consideration. So the first one would be multipod. I think multipod is probably our most common deployment. And it's our most common deployment for a lot of reasons. But essentially, what multipod is it's the same ACI fabric, but we split it up into pods. So what do you mean by same ACI fabric? I mean, it's the same APIC cluster. Right? We have 3 APICs in this topology. 1 APIC happens to be in pod 2, but it's the same APIC cluster. I'm still logging into the UI. I'm still viewing that one network, but it's split up into 2 different pods. So how does the networking work if I want traffic between pod 1 to talk to pod 2? Well, in this case, we kind of break some of the rules. We are now start plugging stuff into the spines, which we only plugged leafs into spines before. So now we start plugging other devices into spines. It's kind of we're starting to change the way we do it. But the reason we do that is because in order to connect these 2 pods together, we're going to run OSPF on the spines, and we're going to peer those to what's called an interpod network, an IPN. There's some considerations on your IPN. It has to support sub-interfaces, because we have to use sub-interface with encapsulation VLAN 4. It's a requirement. It also needs to support an MTU size of 9150 bytes, because we want to do jumbo frames potentially, and VXLAN adds a 50-byte overhead, so it needs to ensure the platform supports that, right? And it also needs to support PIM bidirectional multicast. Now, why does it need to support multicast? Because Carlo mentioned when we have flooded traffic, it uses that multicast address range on the bridge domain. Well, now that's being extended across some other network, and it needs to support the ability to transport that multicast traffic. So what are some of the advantages? Well, this is still all one fabric, and despite it being all one fabric, or because it's actually all one fabric, you can keep policy in both pods. So I can have active here. I can say I want EPG 100 to be on port 1 on leaf 1, and that's in pod 1, but then also be on port 1 in leaf 10 in pod 2. I now have seamless layer 2 communication. I might have seamless layer 3 communication, and I'm using the APIC to push that policy. It can see all these leaf switches, and so it's relatively seamless. We also are able to increase our scale of the fabric to 400 leaves. So if you have a single pod, we are limited to 200 leaves. It's a relatively big fabric. But let's say your business is doing great, and you go to your boss, and you need to buy some more gear, and you're over scale on a particular pod. You could leverage multipod and increase your scale. This is also a really interesting feature as well when it comes to what if my cabling in my data center is a little restricted, right? Let's say I have this massive fabric. I got 6 spines. I got all these leafs, right? It's going to cost a lot of money in cables and SFPs if I want to plug everything into everything, right? It's a very large full mesh network now. So multipod's a really good way to leverage maybe some consolidation there, because now I'm just plugging the spines into these IPN networks. I might have a few interfaces per spine. I'm saving money on cabling, but I can still map these pods together and allow communication to work. So it's a very common use case, I think, with multipod. Limitations here, again, it's a single APIC domain, so if for any reason all 3 of your APICs were to just go, completely on the floor, you're still, limited to that's the APIC cluster, so that's still, from a management perspective, it's all one. We need dedicated devices that we talked about that support what we need, And when it comes to the latency that we support between pods, we only support 50 milliseconds. So it's fairly conservative, but still very, very common if it's in the same data center or maybe across the street, or it could even be a little farther away, but there is a consideration with the latency requirement there. Question.
Now, I see you say have 3 APICs. Is that the minimum number of APICs you have to have? Is there a maximum number of APICs you have to have?
Great question. I'm surprised you didn't call Carlo out for this earlier on. Yeah. So the question is, we have 3 APICs up here. So is that the minimum amount of APICs required to operate a cluster? The answer is yes. Now you can theoretically have a single APIC cluster, but it is not supported in production. Now, why is it not supported in production? Because it's not redundant, right? We need you guys to have redundancy here. It's a huge thing. So yeah, 3 is the minimum. We support more than 3. We support 5, and we're starting to increase scale higher. But 3 is the minimum to run a cluster in production. Yep.
The IPN routers, is that a different kind of hardware? Is it also a 9K, or is that some, what is that?
That's a great question. So the question is for the IPN routers, is that similar type of hardware, Nexus 9K? The good thing is it doesn't matter. As long as it supports our requirements of PIM BIDR with 9150 MTU and OSPF with sub-interfaces, it's completely up to you. So a lot of customers actually have gear that supports it, and it's already repurposed, so they can plug it in.
We'll have to use, in the same data center, right? Like we said, we'll have too many leaves. Can we just have a spine-to-spine direct connection, or have to get a router?
That's a great question as well. Can we have a spine? Can we just connect the spines back to back for multipod? The answer is not currently, but we will talk about multi-site coming up, in which case we can leverage something that's similar. Okay, I'm gonna do one question because I want to make sure we finish. So yeah.
What if you have a branch office? Do you need 3 APICs at a branch office?
You need 3 APICs to successfully run a cluster. So typically what happens, I'm sorry, the question is if we have a remote office, do we still need APICs in that office, I guess? Yeah, you don't need to, but it's always best to spread out those APICs in different pods, because what happens if one of these pods goes completely offline, right? We want to still have a portal we can log into and check the status of the switches in the other pod. And we do have things called a standby APIC as well, which we haven't talked too much about. But a standby APIC is an actual APIC that's sitting there with all the config. It's just not joining the cluster. And you can actually promote those. So if you run into a situation where your data center is now cut off, you can sometimes leverage a standby APIC to kind of promote that cluster back to a healthy state. I'm gonna move on now just to make sure we finish in time, but that's a good overview of multipod. Okay, the next thing that we have is called remote leaf. And so remote leaf is interesting because it's meant to satisfy the requirement of, hey, I might have this small office, the small branch office, and port density is not really a problem for me. And I don't want to buy spines just because I need to plug them into an IPN. Right? Like it's a small office, I just want connectivity, and I want it back to my APIC cluster. So if that's the use case for you, you can leverage what's called remote leaf. And what's cool about remote leaf as well is that we no longer require the multicast configuration. We can actually unicast or head-end replicate traffic that's to a multi-destination. We'll use this in multi-site as well, which we'll talk about. But remote leafs essentially could be a couple switches that you have in a branch office. They'll plug into this inner site network or this IPv4 routable network, and we'll send traffic between the primary site and your remote office using this IPv4 network. So again, what are some of the advantages? It's great if it's a small site. We can save cost on spines. We have no multicast requirements. So if you're worried about the complexity of that, or if you just don't have the equipment that supports it, that's no longer something we require. As far as limitations, for all the traffic, it has to go back to the main site. So when thinking geographically about how we're deploying remote leaf, we have to be under the consideration that traffic will always go to the primary ACI site before it goes to their end destination. So if you're sending traffic in a location that's relatively close, you need to hairpin that traffic. So something to take into consideration. We've upped the latency restriction for remote leaf to 140. And obviously, port count is a concern. We're not going to have a ton of leafs here. So if you need a full-blown data center, it would probably be best to leverage multipod or some other solution. What other solutions do we have? We have what's called ACI multi-site. Now, with ACI multi-site, it's like multipod, except that we have 2 separate ACI fabrics now. So we have 2 separate APIC clusters. They're all being managed separately, and we want some way to have policy across both and also be able to stretch that traffic and manage it from a single place. So with multi-site like Remote Leaf, we no longer require multicast. We just require that we have an IPv4 routable network to connect our two sites. And furthermore, we have what's called the multi-site orchestrator, or as some of you may know, the multi-site controller. And this is a portal that has a connection to the API on both sites, and you can create your constructs, your EPGs, your bridge domains, your layer 3 outs, et cetera, and you can push them to the sites. So we can actually stretch policy, and we can manage policy through the MSO. We can also see the health score of both the fabrics. We have a single pane of glass for all of my deployments. It's a very powerful tool and allows us to synchronize policy all while keeping the failure domains of the cluster separate. Question?
Is there a typo on the slide which says IPN? It should be ISN, I guess.
Yeah, this is the IPv4 inter-site network. The IPN is wrong. Great call out, Carla. Make a note. I'll change it for next year. Thank you. Sir. Yeah, that is wrong. It's ISN. So what are the advantages? Well, we have two completely independent clusters, but we have the ability to synchronize and manage policy between them. It's very powerful. If we have an APIC cluster go offline in Site 1, we still have a fully healthy cluster out of the box in Site 2, and we can use it to manage that traffic. As far as how the MSO connects to the APICs, it uses the out-of-band management address, and we support up to 1 second latency there. That gives us a lot of flexibility as far as where these things are, right? And currently, but we're still trying to enhance this, not all configuration can be managed from MSO. There are still times you may have to log into the individual APIC cluster, do some type of configuration, but for the most part, all of the important configuration you would do to get traffic to work between sites and to manage and monitor both of these sites is done via MSO. So it's a very, very powerful tool. Question?
The intersite network, that's just a regular IPv4 routed network.
Correct.
Considered part of the underlay, or there's no VXLAN over that?
So the question is when it comes to the intersite network, that's just a normal IPv4 network. There's no underlay there, correct? But there is VXLAN. We are still sending our traffic encapsulated in VXLAN across the IPv4 network. So what does the IPv4 network need to provide? It needs to provide reachability between our TEP pools that we've configured, right? Because we'll still be encapsulating that traffic and sending it across. Great question. Okay. Yeah.
MSO, is it a separate set of APICs, or is that just browser access?
Yeah, another great question. So is the MSO, is that a separate set of APICs? Is it allow browser access only? So that's actually their virtual machines. So you can deploy them on a SCVMM cluster or a VMware cluster, and they communicate over a clustering technology. It's actually running on Docker. So yeah, it's very lightweight when it comes to, I don't have to buy servers for this. I can just spin up these VMs, and they can communicate to my sites. And then from there, you log into a web browser, and you configure your sites, and you configure your basic config and get that stretched. The MSO exists in a single location, and then from there, there is a strategy for redundancy. I'd have to get back to you on that, but the MSO is deployed anywhere and can connect anywhere as long as the out-of-band management network is connected to those sites. Yeah, last question. Yeah, there is licensing requirements for multi-site. So the question is, what about licensing? Yeah, there is. We require the Advantage license for multi-site. So there is additional licensing for multi-site. Can you guys come talk to me after? I want to make sure we finish. Sorry, yeah, just come talk to me after. I'll answer the questions. Thanks, guys. All right, so we've kept you guys into the weekend, but hopefully it was worth it. We're going to talk about troubleshooting tools now. It's something that Carlo and I are very passionate about. I think it's definitely a miss to assume that when you're buying new equipment, you just don't need to know how to troubleshoot it. Right? We need to know how it works. We have a good understanding of how it works, but what are some of the tools that we have to troubleshoot ACI now? Because at the end of the day, you don't want it to happen, but your phone may ring on the weekend, and you want to try and resolve that service problem as quickly as possible. So, the first thing would be faults. So we talked about how faults are raised for configuration problems, if things are not pushed correctly. There's a variety of reasons why a fault would be raised, but this is a good indication that something's not working, right? So if you're trying to troubleshoot, hey, I have this flow that's not working, or hey, this policy isn't getting pushed, check your faults. See if anything got raised. And furthermore, if you go to the fault, there's a troubleshooting tab on the fault. What is this showing? This allows us to specify a time window before and after the fault was raised, and it will show us all audits that were changed. So Carlo gave me a lot of grief earlier about making changes. Well, you can see here that he's mucking up my fabric. So it's very important that we can go and check to see what might have triggered this fault, right? And we can see what changes may have invoked it, so we can go and talk to that person or use this to help troubleshoot. Okay, the endpoint tracker. So We talked about how the endpoint tracker is now going to allow us to see all endpoints in the fabric because this APIC is learning all these endpoints. It has a good way of seeing them all. And the endpoint tracker is a good way to just search all endpoints. So I showed you on the EPG how you can go to the EPG and say, hey, these are my endpoints. Well, if I don't know what EPG it's in, I can search. So the APIC gives us the ability to say, hey, they're talking about problems with these endpoints. Let's go see where those endpoints live, and let's go drill into that policy. Right? That's really powerful. It saves us a lot of time. And furthermore, in this endpoint tracker, we can also see events. So we can see maybe there was some instability. Maybe we have IP learning enabled, and we have that dynamic load balancing config that we talked about. We'd be able to see that by looking at the endpoint and seeing, hey, there are things moving here. It's getting detached and attached. It's moving between my VPC port channels. We can leverage that. It's important to note that these notifications are actually rate limited in a sense. We're going to talk about how we can view in real time all the moves and what applications we have to see that coming up. OK, well, what about, do I have any tools that I can use to measure packet loss in my overlay? Yes, we do. We have a cool feature called atomic counters. Carlo mentioned atomic counters briefly when we talked about NTP. It's a requirement if you want to use this feature. But essentially, what is it doing? It's saying, for a given flow, it can be as specific as a source test MAC, a source test EPG. It can be very specific, and it can even be a specific filter. Say, hey, only measure the packets between these two hosts and only ICMP. And what it does is it measures the packets sent from the ingress leaf and the packets received on the egress leaf. So what is this showing us? It's telling us as if we're dropping packets in the fabric. Right? This is very useful because you might have someone come to you and say, hey, I'm having an application performance problem. I'm dropping packets. Well, you can set up an atomic counter policy and say, well, we're not dropping any packets here. It can't be the ACI fabric. Maybe it's something downstream, maybe the physical cabling there or something else in the network. Right? Now, if you are seeing packet drops, you want to probably check your faults. Maybe you have a fault raised for some CRC errors, some FCS errors, things of that sort. You could have a bad cable somewhere. It could be as simple as some physical issue. But anyway, what is this showing you? Is it showing you, do I or do I not have packet loss? It's a nice thing to just rule out right away and help us kind of move on in our troubleshooting methodology for a given problem. The next thing we have is span. So who's ever called TAC and they were like, hey, can you guys get a span session configured? Because we need to see exactly what this switch is doing. Okay. If you have, it can be a little deflating because you might have to go to the data center and plug a laptop in with Wireshark and set up that span session and see that. It can slow things down, right? Well, with ACI, what's great about span is that if we have any endpoint that is learnt, the IP address is learnt, so it's part of a bridge domain with routing, we can send ER span traffic to it. And we make it very easy to do that. And furthermore, because EPGs could exist across multiple leafs, we can say, hey, can you just span everything in this EPG? And what happens then is the APIC will dynamically push a span session to the leaf if the EPG is there, kick up ER span, and start sending traffic to your ER span collector. So it makes it very easy to start capturing traffic in ACI. There's not really an excuse anymore of like, we have to go drive to the data center. It's like, typically, if you have routing enabled, you'll have some type of device that you can clone and get learnt in the fabric and start sending traffic to it. So it's a very, very powerful option in ACI. Question? Okay, so the question was, they were told that when you configure a span session, there were times where you had to reboot the leaf in order to bring that span session up. That is not expected behavior, in my opinion. The issue you could run into with span is limitations on how many span sessions we support. Right? So if you start deploying multiple span sessions and you overrun the limit of the amount of span sessions that we support, when you reboot the switch, depending on when the policy gets pushed, that might start working for you. But no, span sessions should be able to get pushed on demand and be enabled and turned off on demand. So we can follow up more after the session on that, but that's functionality that should exist out of the box. One other great feature about ACI is we're using this controller to push all of our policy. Well, the controller knows about our scale, right? It knows how many objects you've created. It knows how many things are on the leafs, so it can measure scale. So we can use a capacity dashboard to see kind of, hey, where are we at? We want to go and add 100 more servers next month. Is that going to work for us? Do we think we're going to blow up our scale on the leafs? We can use this as a tool to check. So in here, I wrote a script to just kind of max out the amount of VLANs that I support on the switch, and you can see the capacity dashboard picked it up. So as you're making changes real time, it's reflecting real time, and you have a good view of what's currently deployed in your fabric as far as scale. Okay. Now I want to take a few minutes and I want to talk about apps because personally I think apps are a differentiator for ACI. We have this concept called the App Store where customers or Cisco employees, whoever it is, can write an application. And it goes through a review process similar to, I'm sure, what Apple or Android has. And then based on that, we can then approve it and we can make it public for customers to use. There are a couple of really, really cool apps that we have right now that can leverage troubleshooting in very specific ways. So depending on your use case or what you're looking at, these certain apps may be helpful. Let's start off with one app called Network Insights Resources. So what NIR is allowing us to do is it's allowing us to take a time window, which I would argue is probably the most important thing when troubleshooting anything, right? Is it currently happening, or did it happen previously? But what time were we focusing on? So we can set a filter and say, hey, can you show me everything that was happening for the last 15 minutes? And what will happen is it will consolidate all of the audits, all of the events, and all of the faults that got raised or created or deleted during that 15-minute time window. So we can go and use that to see, okay, hey, what's happening here? Furthermore, maybe we know that the problem was related to VLAN 100. So what we can do is we can set a filter that says, hey, the description equals VLAN 100, and it will filter those results down even more. So it'll say, hey, during this time window for this VLAN, we had 20 audit entries. Let's go take a look and see what happened here. So if we double click on that, we can see all the information about it. We can see Carl is at it again. Can't seem to get to this guy. I don't know what his problem is, but he's making changes without change control. He's really, really messing with me here, but I can easily determine what the problem was by using NIR and filtering on that time window, seeing what the changes were, and digging in onto those changes. So very, very powerful. Now, depending on the hardware you have as well, we support what's called flow telemetry. And flow telemetry is interesting because it can integrate with what we call anomalies. So what are anomalies? Well, by definition, they're things that are different, right? They're hey, this was working this one way. We have data over the last 4 months that things were working this way, and now all of a sudden we detect an issue. We can raise an anomaly. And so we can use flow analytics and the anomaly to see what might have happened. So flow analytics allows us to actually set certain flows and check if there may have been drops or changes in that particular flow. It's very powerful. So in this case, we have a flow here. It's saying a packet drop is detected due to policy drop. And we can dig into it. We can say, yeah, okay, I have my source address, my destination address, my source EPG, my destination EPG, and I can see the traffic is connected on this leaf, and it's getting policy dropped. Now, what does policy drop mean? We don't have a contract. Exactly. So we have a bucket that we have for this is getting policed. There's no contract. Now, this is an anomaly. Something may have changed. Well, if it was working and it stopped working, either your endpoint learning is different or maybe someone deleted the contract. So you can go and use the NIR resources to see all the audits and really kind of dig into what might have happened here. What am I trying to highlight? We have the ability to tell you what's happening. All right, this is very, very useful. We can tell you on these leafs, this packet is dropped. And it wasn't being dropped before. It's happening now. Right? So it's really powerful.
Dumb question.
Yeah, no dumb question. What's up?
Are these apps free?
NIR resources you can download and add. Carla, is there licensing for flow telemetry?
Flow telemetry is a license feature, and it requires real hardware. But this is like from the ASIC, so it's pretty powerful.
Yeah. Great, thank you, Carla. The answer to the question was flow telemetry does require additional licensing and some newer hardware, but the NIR resources is available to you, which is great. You can still filter and search your audits and faults. It's really helpful. Okay. So cool, we have this NIR app. Well, we also have what's called the ELAM app. Who knows what ELAM means? Anyone here know what ELAM means? No? Embedded Logic Analyzer Module. If you work with TAC on any platform, they probably have used ELAM if you're giving them a troubleshooting scenario where things cannot communicate. Because ELAM is very powerful. It allows us to set a trigger on the ASIC for a particular frame. So we can say, hey, can you show me if this packet that has this source MAC and this destination MAC, can you tell me if it's getting to my leaf? That's really powerful. Like, is the packet even getting there, right? And then if it's getting there, what is the switch doing with it? It'll go through this whole forwarding pipeline, and it will tell you all of these things. And the problem with ELAM, though, was it was kind of cryptic. So you kind of had to be a TAC engineer or someone really familiar with it to kind of understand what the results of that forwarding decision was. So fortunately, we have a really good friend, Takia, who's doing the session on routing. I think it was mentioned earlier on Thursday. He kind of took it under his wing to be like, we can do a better job of this. This is a very powerful tool. We can give this to customers. We can decode the results for them, and we can show them what all these things mean. And he wrote an application to do it. So what you can do is you can go on nodes, and you can set your filters. And then if you check the trigger and you see a report is ready, that means the packet came in and we can digest that report. So if you look at the report, you get a lot of really good information here. You get the layer 2 and layer 3 headers if there is a layer 3 header present. You have the ingress interface, and more importantly, you have what is happening to this packet. So I know this is the similar example to what I just showed with NIR, but what I'm highlighting here is that it's also showing you the same thing. Security group deny, policy drop, no contract. We can validate the same thing, right? Now, I'm not showing you in the slides, but what this is really great for is, let's say someone calls you and says, hey, I'm having problems, I can't ping this thing. Well, you can set up an ELAM and you say, well, yeah, the packet got to the leaf, it got to the spine, and it got to the egress leaf, and the egress leaf said, I'm forwarding this packet properly, right? That's good evidence to have to say, I think ACI is completely fine, and the app gives you the ability to set these things up and check the results in a very human-readable format. So really powerful. Okay, final app I want to talk about is what's called the Enhanced Endpoint Tracker. Now, fortunately, the person who wrote the app is in the room, Andy Gossett. So Andy's been really instrumental in kind of thinking about what applications we can develop. So he's got actually a session on the ACI App Center on Thursday. If you guys are interested in how this works, how to package apps, how to develop apps, he's got a session. So he's definitely the guy to talk to. What I'm trying to highlight here is that I mentioned the endpoint tracker in the APIC a few slides ago, and I said how they're kind of rate limited in a sense. Well, this application is actually subscribing to the move events on the leafs themselves. You're getting real-time data as to all the moves. So if you're troubleshooting a problem where there's latency or maybe there's an application performance problem, you can load the endpoint tracker and you can focus on a particular endpoint and see what the move count is, right? You can say, hey, there's 144 moves here in the last minute. Like, what just happened here? We got to check this out. So it's very powerful. Now, the question you might have then is, well, where is it moving? And so there's detailed information about all of the moves for a particular endpoint. You can go and say, hey, it's staying in the same VLAN, but it's moving between switches. So it might be moving between switch 1004 and 1010, and it's moving between ports. So you can easily identify the source of the moves, check the configuration there, validate if it's correct or not, and use this to help debugging if there might be any endpoint instability in ACI. We talked about the migration. Endpoint instability is something you may or may not see, and if you do see it, you can use these tools. It's very, very helpful. We talked about off-subnet learns, and if you took my advice and you're going to walk out of the room today and migrate to ACI, you should not have any of these problems, but what I'm trying to highlight to you here is that it's got the ability to show you pretty much anything you need to see with your endpoints. So you can say, hey, I have a list of off-subnet endpoints here. I did a network-centric migration. This is not correct, right? I went to that session. That Joey guy told me it's not correct, so I'm going to take his word for it. And you can see, OK, we need to go and see what's happening here. Maybe we're missing limit IP learning to subnet on some bridge domains. Maybe we don't have the enforced subnet check configured, right? These are things that we can use. But what I'm highlighting here is that there's lots of visibility into the endpoints. So before we wrap up for the day, theoretical Sunday, are there any questions about some of the troubleshooting tools that we've got? One question.
About any of the apps. If you add a new app to your APIC environment, are there any kind of, I guess, does it tax your environment or any kind of downsides to loading up with all kind of new apps?
Yeah, no, that's a great question. That's hey, well, I go and I put all these apps on my APIC now. Well, my APIC is like a production network, right? There's no any downside to doing that as far as resources. They run in containers, and their containers are limited to certain memory sizes, certain CPU sizes. So it's the intent is that we set up limits where you can have many apps and it does not affect the performance of the APIC. Okay. Yeah. One more question here.
I operate in an air-gapped environment. How do I get these apps into my environment? Are they somewhat certified? Is there some kind of signature?
Yeah, it's a great question. So the question is, you know, if you work in a secure environment and you want to use these apps, so are these apps certified in any way? I guess it depends on the certification you're asking for. What happens is when they get uploaded to Cisco, we do some validation. We say, hey, what is this app doing? We check to make sure that it's going to run. First of all, right, it's not going to cause any potential problems. And we actually work with the developer as well to try and make sure that this was built in the way that the framework we give them is going to work in the same way. And then we stamp it with a signature that says it's gone through the process and it's on this website for public available use. Depending on your use case of your security, I might have to follow up with you on specifics, but what's the highlight? It goes through a process, it gets reviewed, it gets stamped, and it gets published. So they should work if they're up there. I'll do 2 more questions. There's one over here, and then I'll do one here. Yeah.
So in that scenario, could you get those to an ACI simulator? Because I'm running like a simulator at
The question is, can we do it on an ACI simulator? Sorry, I'm going to consult Andy on this one. So,
Yeah, so you can run all the apps on an ACI simulator, but the question is going to be, what is the app doing? If the app is doing something specific to data plane, it might not work. But if it's all model-based app, it should work just fine.
So, but it can't connect out, so how do I get it into the simulator? I just go download it?
yeah, so it's a file you download and upload. So as long as you have IP connectivity to that simulator, you can from your laptop, you can upload it. Okay, one more question.
So my question is on interconnecting data centers and the migration part of it. So how do I connect my ACI data center with a legacy data center? Is an N2 extension okay for that?
So the question is, when it comes to the migration, how do I have the layer 2 extension between my existing data center and my ACI fabric? I had some slides that demonstrated that.
I'm talking about data centers like the primary data center is the ACI fabric, and the DR data center would be the legacy data center. So having a single N2 extension.
Okay, great. Yeah, so I want to have different sites essentially, right? But one of them is an ACI, right? One of them is a normal legacy data center. Yep, so we support just layer 2 extension. So as long as we are chunking a VLAN out of ACI, you can do whatever you want with that traffic, right? If you can leverage OTV, you can leverage other things, right, to get that traffic there. But obviously, if it's not 2 ACI fabrics, you can't leverage any of the things we talked about with the multi-location deployments. But you can still connect 2 ACI fabrics back to back by just extending that VLAN out of ACI to some technology that can, get it to where the destination is. Yeah, and then one more. So we're almost done.
Once we
I'll talk to you after.
migrate the network centric to the ACI, then we have multi-site. We can extend that to VXLAN, right? So the IP range can be extended to the other data centers.
Yeah, so the question is, once we have the 2 ACI fabrics with multi-site, we can extend that policy across both. And
IP.
yes, well, yes. So you can have devices that are in the same subnet communicating across sites, and you can have devices that are across subnets communicating across sites. It's a lot of flexibility. Okay, so I know that it's been a long session, but I just want to end off real quick with what do you do if you are looking for more? Well, you're at Cisco Live. That's a good thing, right? So you can go and talk to a lot of people at the World of Solutions. We'll be there for a while. We have sessions throughout the week. This year, we're doing something new. It's a troubleshooting track. So we have hour-long sessions focused on troubleshooting specific features and functionality in ACI. If you want to go after the fact, what would you do? Well, you go to the support forums. The support forums are great because we have TAC engineers, we have BU people from marketing and escalation, and we have customers that are subscribed. So it's really great to always see conversations happening on the support forums. And furthermore, we also have a Facebook group. This Facebook group is great. I think every year I have to go and update the members section of the slide because it just keeps growing in numbers, and it's great because it's not only like the support forums where we have people from Cisco on there answering questions. We have really cool customer interactions that are happening on the Facebook group. So if you want to join the Facebook group, post a question. Maybe you're having a problem, you want some advice. We also use this portal as a way to get the word out. If there's something that we want to really tell our entire ACI customer base or trying to get the word out about some new feature or some new issues that we're seeing and what the workarounds or whatever that would be, the Facebook group is great as a way to just kind of, hey, be aware of this and spread the word. And finally, we have the TAC. I spent multiple years in the TAC. I love the TAC. The TAC will solve 99.9% of your problems. If for some reason they can't, they may come to my team. So it was great to be able to talk to you guys today. And I hope that I don't have to speak with you on a regular basis, just given my job role. But it would be obviously a pleasure to speak to you guys in the future. But what am I trying to highlight? The solution support's great. They have great engineers 24/7 that can help you with any ACI problem that you're having. If you purchase the contract, call them up, and they'll be willing to help you. So thank you very, very much. Please complete your session evaluation. We make these sessions for you guys. You guys being here allows us to come up here and spread our knowledge of ACI and hopefully give you guys some insight. Tell us what you liked. Tell us what you didn't like. We're happy to support feedback, and please fill that out for us. After that, enjoy Cisco Live. It's been a great 2 hours talking to you guys today. Thank you very much.